We are seeing the implementation of the insertion, deletion and traversal in Python. So I'll give you the Python code and explain how does it happen. So first we create a class node and then we create a function which is by def and underscore in it, and in this we put a value, and what this does is self dot value equals value and next. This is a class node, and what we will be doing is that a class node, it is like this is basically a blueprint or a blueprint of a node. So what we'll be doing is all the nodes will follow the structure of this, and you must be wondering what does init means. Init is basically a constructor and it's for initializing the value. This will come under the concept of OOPS, object oriented programming in Python. So but for now, most of the time this class will be defined already, but I'm just giving you for the sake of explanation. So this class will usually be defined in the coding problems, but in real life you have to define it by yourself, and it is a data structure which is not readily made. It's not like directly accessible, you have to first make it. And also over here you must have a thing called as self also, so it will be self comma value. So this is basically the entire structure of a node. So this is the structure of a node, and of this blueprint, like this is the blueprint, and of this blueprint there will be multiple objects which I make. So this comes under the concept of OOPS. So yeah, so now let's create an object. So a is equal to node 20. So what has basically happened is an object of the class node is created. So a is an object. Now I'll make another object like b. Now I'll make another object b node of 40, and I'll make another one which is b node of 60. So now basically what has happened is like three different objects have been made. Now what I'll do is I'll combine all the three objects. So what I'll do is a dot next is equal to b. So what has happened is that I have linked it. So initially what happened was a, b, c was made. These are the nodes, and each node has a value of like 20, 40 and 60. In this what I did is a of next is equal to here, so I just combined a with b and c. Now what I'll do is I'll again do c dot, I'll do b dot next is equal to c. So basically I just combined this was already there, and then I combined it with c. So this is how you create a linked list, and you create nodes and objects, like basically objects of a linked list. And yes, so this was everything about creation of a node and linked list structure slash class. Now let's see the code for printing. Let's just create a linked list. So I'll be like, first let's create a class node, and inside the class I'll make the constructor function, and I'll initialize it, and in this I'll be also thing called as value, or basically data, value or data, anything. Now what I will do is, let me just remove this, and I hope it's visible. Yeah. So now what I will do is that I will create a self dot data equals data and self dot next is equal to none. So this is how a structure of the node is created. Now creating objects of the class node. So A is equal to node of 1, or you can keep, so inside this we are passing the values or the data basically, and I'll do one more, and I'll be like B and C, and here 2 and 3. So these are the thing. Now what I'll do is A dot next is equal to B and B dot next is C. Okay, so I have made 3 nodes and I have linked all the 3 nodes. Now we'll see for the code, but now we'll see the code for iteration through a linked list. So for that, what I do is that, what do we have basically? We have A, B and C. So now what I'll do is I'll create a pointer, and also one more thing, each linked list has a thing called as, this is the head always, and what I'll do is I'll create another pointer which is called as current. So let me just shift this a bit down. Now I'll create a pointer called as current, and this current will iterate through everything and do. So let me just tell you the code for it. So what I'll do is current is equal to head, and then while current is not equal to none, I will be like print current dot value and current is equal to current of next. This is the code. This is the code for printing, or basically iteration through a linked list. So let's just see it in this thing. So what I did is, so I'll just define the first position of head, which is at the A. This is the first node, and also I'll be creating a current which is also initially at the first position, and then I'll be like while current is not equal to none, or basically, so this current will basically go, basically this current will go from here, then here, then here, then here. So here basically it is none. So until it doesn't reach to the none position, I will be like print the current dot value. What are we calling it, as value or data? Okay, data, current dot data, and current is equal to current dot next. This is how you send the current to the next position. So basically this current which you see, so basically current is over here. So now in order to make this make this current go from here to here, what I do is current is equal to current dot next. So current dot next. So the next position of current is this. So I just equate the current which is over here. It has to go over here. So that's how you just shift the positions. And yes, that's pretty much it. So let's just run this, and you can see it is printing. And I'll just be like end it with space. This should print, yeah. So see, is there. Now suppose if I create another node which is like D is equal to node of 70 and C is the C dot next is equal to D, and now if I print it again, so you know the 70 will again get attached to this. Da, 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 na, na, na. La, 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 la. पहली नजर में ऐसा जादू कर दिया, ऐसा जो तूने मुझे ही किया, मैं हूँ यहाँ. Oh, sorry, we didn't actually equate this current to head. We again didn't bring it back to the head position. And now if we do, we should get it. Yes, and I'll just print so that there's a distinguishing between them. Haha. Or we'll just be adding 70. Yes. Yeah. See, if you can see 1, 2, 3, and then I added 70, and I again equated the current. So basically, current is just like a pointer, and now you can see 70 got added. So yeah, that's it about. So what did we see? So we saw until now of a linked list, and now we will see deletion of a node. So now this can be classified into first node, the last node, and the kth node, which is somewhere in the middle of the linked list. So let's see the code one by one for all of them. And we also added another one which is D. Okay, so this is the linked list which we have. And now what if I say that I want to delete the let's start with, I want to delete the first node. So let's see the code for deletion of the first node. Yeah, first node deletion. So in this, what I'll do is that all I have to do is head dot next. Head is equal to head dot next. That's it. That's the code. Head is equal to head dot next, and boom. So what happens is this thing goes over here, and this thing gets removed, and yeah, so your new linked list becomes this. So let's see the code. Last node deletion. So the code for this is pretty simple. It's very similar to the code of iteration through a linked list. So while basically always write this, that current is back at the head, is at the head position, and then while current dot next is not equal to none, current is equal to current dot next, and then finally when you reach at the last position you will just be like current dot next is equal to, I'll be like just current is equal to none. So what I will do is, once I have reached to the end, what I'll do is I'll just be like current dot next is equal to none. So let's just visualize it because it will be easier to understand. So let's just copy this and I'll just tell you what did I do. I'll just draw the head properly. This is the head, and initially the current is over here. So what I do is that, so this basically means current goes at the head position, and while current dot next is not equal to none, so what you have to do is this current will go here, here, here. No, basically what happens is the difference between this code, this current not equal to none and current dot next not equal to none, is that current equal to none will basically reach over here, and current dot next equal to not equal to null will reach over here. So what we'll do is, in order to delete the last node, we will always go one position before the position where we want to delete. So this is the one which we want to delete. So what I'll do is I'll make the current go so I'll make the current go till here, and once I reach over here, what I'll do is I will be like current dot next is equal to none. So basically this thing I'll make it as none. Now once I make that to null, basically this will get deleted, and boom, the last node got deleted. This code we done. And once you and the other and so yeah, that was the code about that. And the third one which I told, deletion of the kth node, that is also very simple. For example, I'll just take this again. Okay, so now deletion of the kth node. So basically what I want to do is that I want to, for example, suppose if I want to delete this node, which is this one, I want to delete the second node. So what I will do is that I will go, or maybe just for the sake of a better example, I'll just add another node so that it's a bit clearer. For example, we just have another node which is E. Yeah. So now what if suppose if I'm told that I want to delete the kth over here, suppose k is equal to 3. So first, second, third, this node has to be deleted. So what I will do is, the rule which I told you is that always whichever node has to be deleted, just go one position before that. So I have to stop over here. So the current will go till here, and then what I'll do is, it's very simple guys. Deletion code is, this is how the array was, this is how the linked list was. So what this line does is that it current dot next is this, and current dot next is this one. So what it does is it just breaks this and connect over here. That's it. So this is all happening because of this line. So yeah, this is your code for deletion of the kth element. And let's just, so yeah, So that's pretty much it. Thank you so much for watching.